In this example, I want to revisit the previous example and make a couple changes to the original problem and show you how that affects our hypothesis test. In particular, I want to turn it into what's called a two-tailed test. Okay, so if you recall in this example, according to a vendor, a 50-cent vending machine is supposed to dispense 14 grams of chocolate. A customer suspects the machine has been dispensing less chocolate lately. So I want to change that to a customer suspects the machine has been dispensing, and we're going to change that to we're going to change less chocolate to a different amount of chocolate lately. So this means it could be less chocolate, it could be more chocolate. We don't really know. We just know that it's like a different amount of chocolate. So he purchases chocolate at 31 randomly selected times and records the weights of the chocolate dispensed each time. He then calculates the mean of the 31 weights to be 13.69 grams. And we're still going to assume the population standard deviation sigma is known. So use the hypothesis test to test the claim that the mean amount of chocolate dispensed by the machine, and instead of has decreased, we're going to say is different from 14 grams. So it's not 14 grams. So let's think about how this would change the different steps of our hypothesis test. In the first step, we state the null and the alternative hypotheses. But the thing that would change here, the null hypothesis will stay the same, but the alternative hypothesis, of course, is going to correspond to our new claim, and that's that the amount of chocolate dispensed is just different from 14 grams. So this would just be a not equal, and you could interpret that as, it could be less than or it could be greater than. It's just not equal. And in this case, we would call this a two-tailed test. And when we calculate the p-value, we're going to be calculating the area in two tails. The requirements are still exactly the same. As we move on, when we calculate the test statistic, that is also not going to change. We're still going to have the test statistic of negative 1.90. The next change is going to come when we calculate the p-value. So the p-value in step 3, when we have a test that is two-tailed, so mu is not equal to 14 is our alternative hypothesis, the p-value is going to be given by double this amount. Okay, so it's going to look like, so if I go back up to the picture here, it's going to be the area in the left tail and the symmetric tail on the right side. So we basically are going to be multiplying the p-value by 2. So this area becomes 0.0574. So this is our new p-value. So let's just take a moment to interpret the p-value in this case. And remember, in terms of the graph, the p-value is just the area in these two tails. And then the interpretation is that if the null hypothesis were true, so meaning that the mean amount of chocolate dispensed really is 14 grams, then there's a 5.74% chance, so almost a 6% chance of getting sample data like those observed, meaning a sample of size 31 where the sample mean is 13.69 grams. And in this case, like, if I want to be more specific, that means as low as 13.69 grams or lower, or as high as 14 and 31 hundredths of a gram or higher. So what changes in step 4? So in step 4, remember, the p-value is now 0.0574. So that is actually going to change the direction that the p-value is now greater than the significance level. So that's really an important thing to notice, is that when you have a two-tailed test, it's actually harder to reject the null hypothesis. So in this case, because we multiply the p-value by 2, so in this case, we actually, even though it's a slim margin, we do not reject the null hypothesis. Okay, so it completely, turning this into a two-tailed test, completely changed our conclusion. And we would say in this case there is not sufficient evidence to support the claim that the amount of chocolate dispensed sorry, I should change this, is different from 14 grams. Okay, so for the two-tailed test, we just do not have enough evidence to support that claim.